All right, hello there, and welcome to the AWS Insiders Ask Us Anything series. This is episode number 2, and thank you for joining us today. Before we start, I'd like to thank our ASL interpreter, Jessica. It's really nice to have you with us today. And also, we're giving away a CloudFix hoodie. So as you comment in the chats, ask questions, it'll enter you automatically. So I'll start collecting that now. And it's only one entry per person, so don't feel the need to increase your entries. The best way to win one if you don't get it this week is to watch next week. All right. And the idea of the show, it's an Ask Us Anything series. It's all in the name. So to that end, if you can ask us a question, you can use the chat in LinkedIn and Twitch or Twitter. You'll need an account, but you can use any one of those platforms. Feel free to leave a question in the chat, and we'll do our best to get to it during the show. We want to share some stories and demos and some ideas, but the majority of the time, we'd like to spend answering your questions and just talking about the real AWS issues that you're facing. Whether you're just getting started or you have years of experience, just want to talk shop, talk about some ideas, we'd love to hear from you. It's a pretty fun time we're living in, where we've got all these really cool services on demand. Not just compute instances, but machine learning and image recognition, all this cool stuff that we can play with. So before we get started, I'd like to introduce Rahul Subramaniam. He's the CTO for ESW Capital, which encompasses a family of tech companies, and he's the head of innovation across these companies and a visionary thinker. He's also the inventor of CloudFix, which is a tool that can scan your AWS accounts and find cost savings. And I'll put a link to that in the chat. We did our inaugural episode talking about CloudFix last week. So I'll put a link to that in the chat. And finally, Rahul is a self-described AWS superfan. Can you tell us a bit more about yourself?
Thanks, Stephen, and thanks for having me on this show. So my role as CTO has been evolving over the last 20 years within this organization. We started moving to AWS, I think, back in 2007. And my journey as CTO for this group is so closely linked with how we've evolved with AWS over the years that I'm just really excited to share our experience, our learnings, and also learn from a bunch of experts that we hope to have on the show over the next many weeks.
Oh, well, thank you. It's really good to have you here and be co-hosting with you. I'm looking forward to a great discussion today. And next, I want to introduce Badri, he's been a recurring guest, who's on last week, and he's a portfolio CTO for Trilogy, which is also part of ESW Capital, and he practices innovation at cloud scale. Would you tell us a bit more about yourself, your background?
Hey, Stephen. Hey, Rahul. So unlike Rahul, I'm a late convert to the cloud. I actually spent a bunch of my career on the edge developing various products, but cloud is where the party is. I mean, I've built a couple of products which we'd spent a couple of years innovating, and then AWS came up with something that did more or less the same thing. And so I'm very much in the camp of if you can't beat them, join them. But it does significantly increase feature velocity to be on the cloud. And so I've been building a bunch of products at cloud scale, like you say. It's been obscenely easy to do so.
Well, that's really cool to hear, and we're looking forward to hearing about your experience, especially around today's topic of developing applications on AWS. So we're talking about the cloud. What's the big picture of this discussion? I think, Rahul, you're best positioned to answer that. Why are we here? What are we doing this series for, and why are we talking about the cloud and AWS in particular?
Yeah, so like I said earlier, we made a big bet about 14, 15 years ago on AWS. And we kind of really had the advantage of growing along with AWS and learning in that process. And over the years, AWS has grown in such an accelerated manner that it's really become the operating system for any new application you want to build today. 90% of products today have code that is built in that is basically just utility. And AWS is turning all of these utility into commodity services every single day. And AWS, therefore, is really changing the game on how applications are being built by new age startups in a garage to large scale enterprises. And while AWS is really the bet you want to make, the sheer footprint of AWS services that exist today just make it really, really hard to grasp all of it. And the situation is further complicated by the fact that AWS makes a conscious trade-off in favor of innovation and constantly rolling out new services rather than providing the seamless experience across all of these different services. And that means that every single year or every single month, AWS is just getting a little bit more difficult to use, even though the potential to leverage AWS increases manyfold. So the reason why we are all here, in short, is we want to use this medium as a mechanism to share our learnings and our experiences, but at the same time, also learn from the community. Have questions and comments come in from the community that teaches us about what their new experiences are as well. And together we can hopefully make AWS easy together.
Oh, thanks for sharing that perspective. It is really interesting as AWS gets more and more complex. You can go to Google Images and pull up old screenshots of the management console. It used to be so simple, and now there's maybe more than 100 different screens and settings and things to think through. So it's pretty amazing to see it evolve. But like you said, that they're filling this space of what was once, I suppose, the bread and butter of programmers of writing all this utility code, and now that they're filling that with commodity services that we can use and then not have to worry about it.
Exactly.
So with it, let's dive into this developing applications with AWS topic. And again, for everyone on the chat, just please ask your questions, and we'll get to it as soon as we can. And so this is a big topic on developing applications with AWS. And if you just Googled that exact phrase, you're going to get thousands of blog posts and Medium articles and PDFs, Udemy courses, and there's a lot to sort out here. And even getting started can be a bit difficult. So in preparing for the show, I was kind of thinking about my own AWS journey and thinking about, well, like you said, in terms of how do you see the cloud in the first place? And so from my perspective, when you first get started, you're thinking about AWS as a data center that you can't access. And correct me if I'm wrong, but they see it as, okay, we start an EC2 instance, install, a LAMP stack, that means Linux and a web server and a database and a language. And then you go from there. And so it's basically the same thing as what we used to call co-location. So when I was a teenager, I had a job at an email hosting company. We had a co-located rack, and we can go visit it. And we had, slots 8 through 16, and we could have put whatever we want in there. And it was just a power cable and an Ethernet cable, and that was our interaction. And it seems like when you initially start with the cloud, it's very much that mindset. What do you think? Is that what you see in your experience? People having to do a mindset shift?
Yeah, I think that is in fact very true. So just like your experience, the way I started off with AWS back then, back in 2007, was I had to manage 2 insanely flaky Lotus Notes servers. Now, I don't know how many people still remember Lotus Notes, but that Lotus Notes and Lotus Notes databases used to be the bread and butter of our business. Like everything you did was on the Lotus Notes server, whether it was personnel, HR, finance, project management, ticketing system, everything that we ever dealt with was a Lotus Notes database, and of course, email. And those servers were just so damn flaky that keeping them up was an absolute nightmare. Every now and then we'd have to send someone running towards the data center. They would literally have to drive up to wherever our co-location facility was, get permission to get into the center, then go tweak something, go figure out whether the machine was actually working, reboot it if necessary. I mean, those are the days when you had to do things like that. And when AWS came along with the services like EC2 and S3, and back then, by the way, that was all there was. There was one account. In that one account, you could have only one user, nothing more. And it had EC2 and it had S3. That was it. That was as complex as it ever got. But the idea that we could, with a simple API call, launch the infrastructure, decide what size we wanted, and then install our app, whether it was reboot or whatever, we could do it literally with an API call, was revolutionary. Okay. But you're right in that from a mental model standpoint, it was just a different way of co-locating your servers in another place with better convenience, because now it was just an API call, right? But that was back then when AWS literally was just EC2 and S3. Over the years, AWS evolved into doing so many more things. There was a time in the middle where I think the big trend, and for some, it's still the big trend, which is get onto Kubernetes. Dockerization was an incredible mechanism of having lightweight containers be portable, where you could take them from your data center that where they were running earlier, migrate them to the cloud, and for the first time, you were able to leverage horizontal scale. So you could have a cluster with a bunch of EC2 nodes under the hood, and you could scale up your compute, or you could scale up your containers depending on the load that came in. And that was the second order revolution that was brought about by hyperscalers like AWS. And the concept of elasticity of compute kind of really started hitting home. Where AWS evolved and has been evolving over the last few years, however, is in these higher order services, where they literally have been so focused on taking tons of code that you've been writing, which is just utility code. In fact, if you really think about it, the amount of code that you own today, I'd say about 90% of it is utility code that just helps scaffold the 10% of real business value driving code. All the collections, all the sets, whatever mechanics you have in the way you write your code, all of that fundamentally is just utility that is commonplace. You more often than not just use jars, that you bring in and still own all of those dependencies today. Those are the things that AWS is literally turning into commodity services that you can now leverage literally with a simple API call. And I think that's where the evolution of building applications in hyperscaler like AWS is evolving. It's all becoming the idea that you can stitch together a bunch of these services to achieve the applications and the outcomes that you want.
Well, thanks for that great explanation. And just as in terms of those higher order services, I've got my SQS hoodie on. And again, that's just one of those simple problems. How do you send a message from one service to another? And as a younger programmer, I thought, oh, this is a fun diversion. Let's start coding up something. But then all those thousands of corner cases and edge cases, and how do you deal with failure? How do you make it interact with this? How do you interact with this? And before you know it, you've got a whole other project going that, like you said, has nothing to do with your business problem. It's just scaffolding. And on the one hand, it's fun to kind of geek out on the side projects, but it's not adding value to your business. And it's not going to be nearly as tested as a service like AWS can provide. Other quick comment. It seems like your Lotus Notes comment was resonating. We have from Gleason B on Twitch, Lotus Notes, bane of my life, 97 through 1999.
It definitely was mine for about 3 to 5 years, I think.
So to summarize your comment, you start with this. You start seeing the cloud as on-prem computing, but you're not dealing with the actual nuts and bolts, the actual hardware, but it's still very much in your mind, you're thinking about computers and IP addresses, and then those fundamental building blocks. And then later you think towards containered applications, maybe using Kubernetes. And this point, it's still a big abstraction around hardware. And then in the third stage, we're talking about leveraging hyperscalers for these managed serverless services. And so we're going to dig into this throughout the remainder of this episode, because that's where we think things are going. And then, Badri, let's bring you in. What do you think in terms of, what have you seen in terms of people's evolution, thinking about what the cloud is and how they utilize it? Do you agree or disagree, have different observations?
In terms of the three modes of using AWS, totally agree. Those are like it's a useful categorization of how people use AWS. What's interesting is how people seem to be taking that journey. From what we have seen with various customers, they migrate something to the cloud, run it in VMs, either directly or via VMware or something, and leave their applications running. And it's interesting that they actually switch to step 3, which is managed services for data analytics type of applications. I mean, if you look at, there is a study recently published on where AWS spend is, and a bulk of that is still in lift and shift type of applications like EC2, EBS, S3. But the fastest growing segment is data analytics and increasingly AI, something like SageMaker. And that's what companies seem to be organizationally doing is they don't want to touch their applications. They're a little bit afraid of a rebuild that even does as something as simple as containerizing their existing application running on VMs. Instead, they want to leave that alone, but take their data and get more insights out of it using something like Glue or SageMaker, or essentially they're doing greenfield projects which don't affect their data path, which is certainly interesting. And while their spend on these applications is only 5% of their total bill, I'd argue the value they're getting is much more than that. So that's one of the things that these services are really helping customers do is unlock the power of their data and actually drive business value.
Okay, so you're saying that they have some core applications that they'll lift and shift to the cloud. So that basically means take them unchanged, but they're no longer, they're just moving it to EC2. But then but because those applications are there and they're generating data and logs and everything there, they can then feed them into SageMaker and other higher order analytics services and then build from there.
Correct.
Okay, so you're not seeing the big rewrite of the core services as much.
I wouldn't say not seeing any of that, but this is as you would expect large organizations to move, right? They don't want to go, I mean, they don't want to make these teams disrupt their everyday work in terms of shipping products and customer support and everything. But now that the data is there, you can actually put an entirely new team on this and try and get analytics out of it and business intelligence and so on.
Okay, that makes a lot of sense. And I think we're going to dig into that further in the show. We talk about architecture and different ways of making this transition to the cloud. So I wanted to come back to a word that was brought up of leveraging the hyperscalers. And so we have this good term, hyperscaler. So let's define what this is. So on Wikipedia, it says hyperscale computing means seamlessly providing and adding computing, memory, network, and storage. So in cloud, who are we talking about? Who are the hyperscalers, or what are they, and why is this important?
So,
Rahul, do you want to take this one?
I think as your graphics show, it kind of hyperscalers overshadow everything else. So basically, I mean, the way I think about hyperscalers there are three. There's AWS that kind of leads the pack in terms of the sheer number of services and scale and customers and coverage across the globe that it has across all of its data centers and regions and availability zones. And that's followed by Microsoft and Google with their Azure and GCP services. And really, I think it's just the three that have the scale to be called a hyperscaler. And fundamentally, like I said, what's different about the hyperscalers from everyone else is just the ability to allow customers to not think about what they need to go from one server to a million servers if they need peak load to be provisioned for a period of 1 hour. Right? You never have to worry about capacity. You never have to worry about running out of resources or pre-planning or provisioning resources upfront. The hyperscalers have the scale to go from 1 to a million in a matter of minutes and for customers to not have to worry about it, right? And that's the way they manage everything under the hood without customers needing to worry about it. And that's, I think, one of the key drivers, the elasticity that they have far outstrips everyone else that's in the running to be called a hyperscaler.
So when you get to the point where you truly do not need to worry at any size about how much resources you're going to consume, if it's going to work, I guess a great example would be like S3, right? There's no way you could generate enough data to overwhelm S3. You just can't happen.
Yeah, and I'll say that I'll add one other thing just as an anecdote. So I think providers like AWS are just about getting to the part where you can start really calling them hyperscalers. Just as an anecdote, about 4 or 5 years ago, I was running an experiment where they had just launched the X1 E32XL instances. Now, for context, the X1 E32XL is like 128 cores of CPU and 4 terabytes of RAM. And I just wanted to understand how much and how quickly we can scale up or down these instances. So I tried an experiment where I wanted to launch 100 X1 E32XL instances and just scale it right up go from 1 to 100. And as soon as I triggered that, I got a call from AWS saying, "What the hell are you trying to do?" Right? So I don't think customers have that problem today. I think that's an example of how quickly, providers like AWS have evolved, where I don't think anyone thinks about going from, 5 cores or 10 cores to 1 million cores. There are enough and more workloads today that you hear from everyone from the big banks to the large enterprises, again, for use cases like Badri was mentioning, are all around data, where people are using the elasticity of hyperscalers like AWS to literally go from 1 to 1 million for a short span of time and then come back to 1.
It's pretty amazing to think that, if you look at the famous top 500 supercomputer list, and you think some of these now are these top 500 computers, you used to think about, this is a special government facility and it's got, a name and a special logo and all this stuff. But now some of these top 500 computers, they're these ephemeral clusters that exist for maybe a couple of hours to do a certain job, process a batch of video, or I don't know, serve ads for the Super Bowl, or some just large thing that has to exist for a short period of time, and then it's gone. And it's amazing to think about that shift and how quickly it's transitioned. And speaking of shifts, I think we wanted to talk about, we talked about stitching services together, and we also hear this word serverless. And so serverless itself is kind of a funny word. Who are you talking to? You have to talk to somebody. So in terms of serverless and stitching software together and architecture, what does this look like in practice? So when you start solving a problem and you're thinking about, serverless, so if there's no server, where do you start?
Badri, you want to take that?
Sure. This is sort of the other dimension of hyperscaling, right? I mean, as Rahul said, there is what you might call vertical hyperscaling, which is you take something that you're doing and try to do a lot of it. Go from 1 transaction per second to 1,000 transactions per second to 1 million transactions per second. But I think there is the horizontal hyperscaling here as well, which is just the number of things that you can do. And I think you're getting that from 2 different dimensions. One is all the services that AWS itself produces. You can basically build an AI pipeline for just by clicking a button, and SageMaker will do it for you. But I think there's also sort of the network effect of this, right? This is where all the vendors are. I mean, if you look at the companies that are growing on AWS, those are companies that are building services using AWS under the hood. Now, they might be managing servers, but you don't care. I mean, as far as you are concerned, you just put your data in Snowflake and query it. So you're getting that benefit of just being where the party is at. And really the party is at the 3 hyperscalers, and all these vendors are going and providing services there. And you just get to go there, click a button, and use various different things. I mean, think about like what Datadog is doing or Snowflake is doing, or any one of these services that do specific things very well that you don't have to do anymore. So there is that dimension of hyperscaling that you get. And then there is also the adoption of serverless itself, like traditionally taking some code that was running on an EC2 and running it in Lambda. I believe that's the fastest growing segment in terms of AWS spend. But I'd say that there is another hidden dimension as well. There is serverless as far as customers are concerned, essentially just calling an API and using a service.
Okay. Well, that's a really good distinction. And I really like what you said about just that network effect of once you have your data in the cloud, you have access to all these really cool services. Now, I was playing with Transcribe the other day, and they have a new feature for call centers where it'll take an MP3 file of a phone call between a customer service representative and a customer, and it'll analyze every syllable, every sentence for intent, extract all of this really good data out of it. And because it's right there, I can put this into an S3 bucket, and then I can have a quick site dashboard to visualize this, or find analytics about which phone calls are going right or which agents are doing a good job. And it's really neat, like the stitching of things together and knowing what's out there. So Rahul, from an architecture perspective, how do you design these programs? I mean, as a programmer, maybe if I was coming from a C++ background, I'd start thinking about objects. But how do you design these systems to work in this stitched together framework?
Yeah, I think for me, one of the big paradigm shifts was that, we came from building large-scale enterprise monoliths, where the paradigm fundamentally was procedural with synchronous operations. So you would basically make a call to your backend, a bunch of processing would happen, it would return a response, you would deal with it in the front end. That was typically a very synchronous mechanism and a way of thinking. I mean, when you wrote code in C++ or even when Java came out, when you write code for languages like that, all of your platforms are built for synchronous operations. And as a bunch of these utilities started coming up in AWS, where you could kind of it's almost like outsourcing certain functionality to a cloud provider, where you say, okay, go do this for me, and it comes back with a response whenever it comes back with a response. I think the paradigm started shifting to an event-driven paradigm. And the big, I think, aha moment for me on that front was the fact that I kind of realized that also if you had to scale up significantly and figure out how to build for leveraging the elasticity, you had to move to an event-driven architecture where each unit just processes the request that it has and says, it returns back a response and says, okay, I acknowledge that I've got the job, I will do it, and I'll return back a response whenever I do. And that is a completely different way of thinking about how all the different pieces talk to each other, work together to achieve certain outcomes. And it is a paradigm shift. It doesn't come natural to a lot of people. Like our notion of API is still synchronous. You make a call, you get back an answer. And I think it takes a little while to kind of break that mold of how we write our applications. But once you realize realize the benefits as well as understand the foundations of event-driven architecture, then all of these services, almost look like, being a geek. I love all my gadgets. You've got all of these gadgets available for you, and now it's just a question of, okay, what do I put together to create something amazing? So you start seeing the value of all of these services as soon as you kind of embody that event-driven architecture and that framework. And suddenly this whole paradigm opens where every service is a block. It takes a standard input, it produces a standard output, and you have to figure out how to leverage it in the chain. And the chain is not synchronous, it's asynchronous. As soon as this is done, something else will get triggered automatically. right? So once you figure out how this event-driven system can work, you can actually build pretty much anything you want.
Okay, so that's okay. So the big shift is you're not making this call and saying, "All right, service, do this right now," and I'm going to block or I'm going to wait until it's done, and then I'm going to come back. You're going to fire this job out, make sure that it was handled, or that the next service has accepted that job. But then otherwise, you're not going to think about it until it comes back.
Correct.
So here's so thinking about that. How do you, to be an effective developer in this environment, you have to know, well, what are all the services that are out there? And so how do we empower developers in this kind of environment? Is there training, or how do you, what is the process for making developers thrive in this environment? What do you think, Badri? What do you think?
Yeah, I mean, as a developer, your life could be a nightmare, right? With the space at which all these services and all these, in fact, even within a service, all the amount of detail there is in an API, that could be really frustrating. I think organizations have sort of taken two approaches. One is they marry developers to services. They build an in-house, I don't know, Connect expert or Glue expert. I think what we're trying to do a little bit is to make that decoupling possible, where you take these services, just summarize, interpret what's important, and give just about enough control so that anybody can build an application on, let's say, Glue. Because AWS is sort of internally structured that way. They do have two pizza teams running around doing a service that don't really talk to other services, so they don't really care. I mean, I think Werner Vogels made that point in the last reInvent, which is they are interested in creating primitives and letting people configure these services to death. But I mean, that's great. But for a customer who is sort of let's say, somebody who is willing to date a service but not marry it, you need to make it simple to use that service. And that's part of what we're trying to do, is to say, out of all these thousands of controls you have, here are the 10 that you really care about. Just use those. And that's about all most people need to do.
Okay, yeah. So to summarize what you're saying, and Rahul, feel free to jump in, saying at an institutional level, you're thinking about, okay, have developers who kind of are subject matter experts on certain AWS services, so that you have people that you can go to, and then also having tools to support, I suppose, best practice usages of these services, right? You said there's 1,000 different options, but what are the 10 that really matter for your use case?
Yeah, and I think there's another way to slice this problem. I completely agree with Badri. But the other mechanism of doing it is AWS's service catalog spans, like I said, all three levels, all three tiers of the infrastructure. You've got bare metal or bare infrastructure, which is your compute, storage, networking, and so on. Then you've got a bunch of services that are kind of like, middle of the path, where you can, with one click deploy something. It's examples like RDS and a few other, services that they have, which SQS, SNS. There's some examples of services that are kind of almost like middleware services. And then you have what I call the higher order, completely managed and serverless services, which do a particular part of business logic or a particular operation for you out of the box. So I would say start top down. Start with the services that are completely encapsulated. They do a bunch of work for you without you having to deal with the nitty-gritty details. They're completely managed services. They will scale for you as need be, and you can put in the controls that you want. Keep it simple. So that's where you have the highest order of simplicity, and things just get more complex the deeper you go. So, but if you start over there, I think there are two ways you can do it. You can take your application, look at a service, and see if your application has a nice seam where you can remove a bunch of your code that performs this. So, for example, if you have a cache, that you built yourself, you could probably, if you have a good API around your cache, you could probably just delete all that code and start calling a Redis cache that's hosted in AWS. Right? It's a managed Elastic Cache is a managed service. Go leverage that. Or if you were building something like a full text search capability across a whole lot of documents within your application. And by the way, we have tons of applications in our portfolio that literally did that. There are millions of lines of code that we own today, which literally just does that. You want good Google-like search, and none of them are even remotely as good as Google search. So, but you could literally just, as long as there's a good API around that search engine or whatever that you build, take all of that stuff out, replace it with a call into a service like AWS Kendra, where you can just upload all your documents and you get Google-like search out of the box. So if that's one mechanism of doing it. The other one is literally just starting from scratch, going back to, again, examples of what is the core value you want to deliver, that you want to kind of realize, and go look at this set of services and figure out how you can leverage them to build a new solution. Invariably, you need very little code and very little, stitching to actually realize really neat applications. Data analysis, like Badri was talking about, is probably one of the easiest ones to get started with, because dumping data into S3 is super easy. And then services like Glue will allow you to transform them in a super easy manner. You literally then start using that S3 data like a database, and you use Athena to write SQL queries and query all the data that you have in S3, and then plug that into QuickSight dashboards that will allow you to slice and dice data. It doesn't get easier than that to manage massive amounts of data. And I think that's why you're seeing a huge influx of newcomers into the AWS world who are starting to leverage AWS for data services and data analytics.
Okay, so to summarize, we're saying when you want to use these higher order services, so one approach is to start with the ones that are fairly self-contained, like analytics, machine learning, where you deliver some data somewhere and it'll give you an insight. And then for some of the lower level ones, you want to find the parts of your application where, okay, this has been a pain point for a while. Like you said, you have your own cache that you've written. You really don't want to maintain another cache. So you can excise that part and swap it in for Elasticache or some other managed service, because you have a good boundary inside your application to be able to do that. So you haven't. Okay, so I really like that idea. So we've talked about it from a developer perspective and an architecture perspective. Now, from an institution perspective or just a more human perspective, what hangups do you see come up either as an institution or just individuals within that who maybe are worried about serverless? I guess one thing I've seen is this whole sunk cost fallacy, right? We've spent thousands of developer hours developing our own machine learning pipeline, so we're gonna stick with that because we've already made one. Or how do we know that it's going to do as good as the thing that we made? So what are other kind of hangups that you've seen, and how do you see those being overcome?
Badri, you want to take that?
Sure. Yeah. From an institutionally, I think if you are, let's say, a CIO or a VP, you should be investing in a data team. Because a lot of the applications that your teams are building right now really ought to become a bunch of service calls. It doesn't have to be AWS services. It can be anything else, but they need to become a bunch of service calls delivered by small teams. I mean, the whole microservices paradigm. But in that paradigm, what becomes important is observability and the ability to reason about big applications in terms of small services that are being delivered by small teams. So you need to invest in a data team that can actually interpret what's happening in your organization and sort of find out hotspots of either teams getting overloaded or teams not delivering what they need to deliver, and go drill down on that. I think that's an important aspect of what you need to invest in. The other thing is, when going into each microservices team itself, it's a great way to organize your work, but each manager of each of these teams needs to adopt some form of a minimalist philosophy in 2 dimensions. One is, don't build anything you don't need to build. Everybody needs to be making buy versus build decisions. And second, be very sort of possessive about your API. Do not let people overload the API more than you need to, because you need to be able to switch from one service to another service. Again, AWS will let you do 100 things, but should you really let your customers do 100 things with a particular service, or just 10? And that gives you the ability to switch from, say, transcribe to auto.ai tomorrow, because you're not using anything that's specific to transcribe itself. You're just allowing a set of functions that are minimal and common. So I think those 2 things organizationally would be very powerful for folks building on any of these hyperscalers.
Okay. I think it requires a big shift in the way you start managing your teams at all levels. Like what you were saying, at the CIO and CTO level, you really have to move away from your backward-looking, spend on infrastructure and the way you manage your stuff, and think forward to say, here's where I need to be in a year. I need to be more agile. I need to, figure out how to get more value by doing less, and therefore thinking about what can I just have an API call do for me. And you start thinking in those terms rather than your sunken cost in your infrastructure or your teams or any of those aspects. So it is a paradigm shift in the way you think about your resources and managing those resources. Lower level, when it comes to engineering, and this is particularly important to me, and this is something that I realized, and a lot of colleagues actually helped me develop this simple question that I ask my teams. So, traditionally, we've always asked our developers to write code that can withstand the test of time. Okay, and in the new modern world of the hyperscalers like AWS, that's exactly the opposite of what you should do. The question that we now ask our developers is, show me how you've written code that is easy to delete. Okay, and this is a fundamental shift in the way you think about how you write code. If you write code that is easy to delete, then you have to have a clean API like Badri was talking about. Okay, you have to have good object-oriented models so that all the functionality is well encapsulated within that little module. So that as and when there's a new service that comes up, there's a new way of doing something, you can literally just delete this and replace it with something new. You have to start thinking about building your applications from the perspective of how easy am I going to make it to adopt a new service, a new utility, a new commodity service that's going to come up with one of the hyperscalers. How am I enabling my system to be able to leverage that? And that requires you to ask the question, how easy is it to delete code that you've written? And this goes against everything the developers have been taught for decades. So it does take a big mind shift change. It does take a certain discipline to overcome that, but that really is at the heart of the change you need to be able to leverage the hyperscalers for the long run.
Well, thank you for that explanation. I've got a soft spot in my heart for functional programming, and it sounds very much the same, right? You want to think about these small atomic functions. They take something in, they put something out, and you don't have this giant state that's spread across your application that then you have to have this really complicated mental model of, wait a minute, this function changes 8 different things. You make the pieces easy to swap in and out different components just based on the contract at that particular junction of what comes in, what comes out.
Exactly.
And I guess, like you said about paradigm shifts, it really is, you really want to work with the system. It's like learning a language, right? You want to do things in the idiomatic way. And you see this like with Python programmers who are coming from C++. And you see if they write their Python as if they were writing C++, it's pretty ugly. But then later they do things the Pythonic way or the idiomatic Python way, and they're starting to use the features of the language that actually make it good. And it's the same thing with thinking about the cloud, right? You want to work with it, and you want to use it in the way that's meant to be, right? Connecting these services together, not trying to, well, to Badri's point, right, to try and overload it and do something that makes it more complicated than it needs to be.
Exactly.
And so, to summarize, right, we're thinking about AWS. We're really thinking about it as the OS now, right? We're not thinking about a bunch of different computers with their own OSs. We're thinking about the platform is the OS, and we're thinking about the services being system calls, and we're stitching together the system calls at a higher level way. So
yeah, I mean, right when I started my career, I used to write, Windows applications and Linux-based applications where you would have to, write at a level where you were either making Win32 calls, if you were building Windows applications, or you were literally writing system calls on Linux systems. And I see AWS services pretty much the same way, where you need to start having these conversations as to what your building block APIs are that you're going to build your application around. And once you've identified those, then the rest of it actually becomes fairly simple.
Okay, awesome. All right, so we've talked a lot of good things about serverless and about this cloud. Now, are there any downsides? Is this a more expensive way of doing things, or is this a more complicated way of doing things, or what are the most difficult parts in this particular journey? Is it more expensive?
Badri?
It is. I think the bean counter answer is yes, it is more expensive. If you take we do this for a lot of our services, is we compare what it costs. Just if you look at your bill, AWS bill, what extra it costs you to run a serverless version of something. And that number is typically between 25 and 75% more expensive. But what that's missing is looking at your overall costs, right? I mean, and vendors generally do a good job of telling you that your total cost of ownership goes down. The problem is, since vendors say so, companies think of that as just sales double speak, but that's not true. I mean, if you look at, we've been on the customer side of this, right? When vendors pitch this to us, it really is true that total cost of ownership goes down, because even today the bulk of IT company costs is really talent costs, like the engineers that need to operate these services. And the more you can free up your engineers to go develop applications, as opposed to just building software that could be done by a service, the more value you're generating for your company. So the sticker cost is 25 to 75% more. In reality, using a managed service or you going serverless will save you at least 50%.
Yeah, and that's a conservative, cost savings. I think a lot of people don't realize, and they don't use this as part of their computation of total cost of ownership. When you are not the expert and it's not your primary business to go manage a service, when that's not your core competency, it is a core competency of AWS. But if that's not your core competency, then you are going to have issues like outages. You're going to have services go down. You're going to have customers screaming. You're going to have customers leaving your products and your business. No one counts the cost of all of that. When you account for all of that, just having a reliable, elastic service that just works, and you have the best team on the planet, driving that reliability, where you will know you have the best security experts, you have the best, disaster recovery experts working on, the infrastructure behind the scenes at AWS. You really want them to do that work, and for you to focus your scarce resources. And by the way, the resources are scarce because the people that you hire within your organizations are the only people who have the domain knowledge to build the features and products and applications that you want. That resource is not something that exists outside. So that scarce resource you want to leverage to do what is your domain and your expertise. Things that are not your core business, that things are not in your core competency, let someone else do it.
So thank you for those explanations. And so I think to summarize, you're saying, okay, from the bean counter, the cloud bill perspective, it'll be higher. But you're freeing up your developers to focus on what you actually hired them for, which isn't to write caching services and database migration services. You're freeing them up to focus on the core value add of the company, and this savings on your developer time is going to swamp any increase in cloud costs. We say that's accurate?
Yeah, I think pretty spot on.
Cool. All right. So then here's one last, I guess, question. So we're talking about this whole re-architecting, and whenever we talked about changing architecture, as a programmer, my little Joel Spolsky blog post of, oh my gosh, are we going down this avenue of the big rewrite? Is this a good idea or not? And so he has this famous blog post about the dangers of rewriting code from scratch, right? And so how do we balance those two things, right? Where do we just lift and shift, or do we? And I think we've already talked about this a bit, where we want to start with the lower hanging fruit, the more isolated services, and go from there. But I guess, do you have any kind of final thoughts on that? Of this transition is worth it versus lifting and shift?
I can take one crack at that, and then I think Rahul has some interesting war stories on this. Rewrite is if you're trying to do a rewrite while maintaining the same feature set and the UI, you're doing it completely wrong. A rewrite is an opportunity for you to think about what's really valuable about the product and do just those 5 things. So I'd say Joel Spolsky is right. If you're trying to take code and refactor it, that's a terrible idea. It's a strategic mistake. But if you take that as an opportunity to really think about what's useful about your product and how you can make it better for your customers, how you can do 10x more of the things that they love and 10x less of the things that they never use, I think that's an opportunity for you to really do small, more valuable rewrites.
Cool.
Yeah, I completely agree with that. And actually, there's a corollary to Joel Spolsky's quote over there. It says the easiest way to bankrupt an enterprise software company is to engage or start working on a rewrite of the entire product. And that actually is pretty true, or used to be true in large part. I think the big game changer has been the way you think about a rewrite. And like Badri said, you have to realize that large enterprise products have evolved over a period of decades, where there has invariably been a lot of cruft that gets added onto your code base, because your sales guys will go and pitch something to a customer. They'll want a feature to sign a new deal in the early stages of the company. That'll just get slapped onto the product because, hey, somebody's paying us. Let's just get started. And then as you build your customer base, as they start using the product more and more stuff gets added, more and more configuration gets added. In some cases, you might actually have different versions of the product for different customers, because each customer went down their own path of customization and you needed to support it because it brought in revenue. There are all kinds of variants of how products evolve over a period of time. And if you start at wherever you are a few decades down and you say, okay, now I'm going to rewrite the product, the right approach, like Badri just said, is to step back and say, what was the core value proposition of the product that customers really loved, and build a new version of that product that removes all the decades of craft of features that got added onto it, and just focuses on that core value delivery. And you can do that with very, very few lines of code in comparison to trying to rewrite and replicate all of that behavior and all of those nuances that got built over two or three decades in some cases.
Oh, that sounds like a really great way of thinking about it. That this is an opportunity to go through it, to really think what are the features that we've just been carrying around for a long time because of that one contract back in '97. All these things that just get maintained a lot longer than initially thought of. That you get to now, okay, think I'm going to make a new version that's more efficient, that's more reliable. It's going to free up my developers to keep iterating on new features instead of paying this increasing a mountain of debt. So I think that's a really neat way of thinking about it.
Yeah,
so I think
we had one extreme case, by the way, of one customer or one product that came into the portfolio where I think it had 12 customers and 12 different versions of the code base. Like every customer had their own version.
Oh my goodness.
And, like that's an extreme scenario of what I was talking about. And if you really want to read, like, what product do you rewrite? Right? I mean, that's not something you want to attempt. You want to really think about what the core value prop is and rebuild.
Oh yeah, what a mess of a situation to walk into. Wow. So we've got 5 more minutes. I wanted to take one of these questions that came up, and I'll put it up on the screen. I'll do 2 of them. Here's an interesting one that I've seen. So in serverless, how do we maintain a big picture view of what's going on? So this person said, right now my AWS account is looking like just a bunch of Lambdas and CloudFormation stacks. How do I maintain my big picture? And I think, Badri, you talked about this a little bit in terms of investing in a data team. Any other kind of tools or suggestions for keeping a big picture of the architecture in this event-driven model where there's lots of little pieces floating around?
Yeah, I think AWS is account-centric, not product-centric. That's the difference between AWS and, say, GCP. But AWS does have good tools to visualize your data flow. So I look at the data flow rather than the individual Lambda functions themselves. And I guess we are developing some products to make this simple. I will probably talk a little bit more about that. But if you have right now a bunch of Lambda functions that are running, X-ray would be a good place to start. Just have everything post events and look at X-ray, and that will give you a sense of like what your application flow is.
Yeah, I think I just add one other thing. It all depends on how you are creating your application. Like, for example, there are different frameworks that you could use to build up your application. Instead of going straight to CloudFormation, leverage CDK, which will help you organize things in a slightly simpler manner. That's one approach. Alternatively, if you find that what you're doing with all of your data or with your application is primarily almost like a workflow processing, then use something like step functions, which will give you a bigger picture summary of what's really happening, and you can orchestrate it all within step functions. Then there are SageMaker pipelines, so you can use SageMaker Studio to define your pipeline. That gives you different kinds of visualization around your ML workloads. So it depends on what you're actually trying to do with your application or with your workload. And there are different set of tools.
Okay.
There are some very interesting.
That's really good practical advice for both the X-Ray, the SageMaker pipelines, trying to keep it more simple with CDK. Yeah, that can be really useful, and especially for people who are used to seeing everything in one big monolith. It can be a little bit scary to think, okay, there's a function here and there's a thing here, but being able to get that big picture view, I think, is really reassuring. All right, we've got 2 minutes left. I did want to give away that CloudFix hoodie and also thank Jessica, our interpreter, one more time. It's a really intense work to take technical discussions in one ear and then translate it. That's really cool. Thank you. All right, let's do this drawing and see how this goes. Oop. And it's going to be Gleason B. So congratulations, you've won a CloudFix Saves hoodie. Reach out to me. I think you're on Twitch, so reach out to me and we will get that to you as soon as we can. Congrats on that. And let's see, just switching back. Thank you, everyone. Thank you for being here. Really appreciate Rahul, Badri, and Jessica. Thank you for the translation. And we'll see you in 1 week's time for episode number 3. Thanks again.
Thanks, everyone.
All right.